ASDIP Wood includes the design of multi-story, multi-bay wood shear walls. But how do you actually enter the information in the program? How do you analyze the results? How do you optimize the design? This is Javier Encinas, and today we're going to present an example of a multi-story, multi-bay building, showing all the design process step by step. Let's get started. As an example, consider this 3-story, 3-bay building. The first story is 10 feet and the upper 2 stories are 9 feet high. The first wall segment is 2.5 feet wide. The second is 5 feet wide and the third is 4 feet wide. The shear wall is subject to different loads, gravity and lateral loads. Dead load 300 PLF, live load 250 PLF, wind 1000 horizontal concentrated load at each level, and seismic 1200 pounds each level as well. With this information we will model this shear wall in ASDIP Wood and will design completely the system. Let's go to ASDIP Wood. When you open ASDIP Wood, you see the project manager. Here we can see the modules included in the package: wood column, wood beam, wood bearing wall, and this new module on wood shear wall. I have already created an example to simplify the process. Let's double click on the example. And this is the template for a wood shear wall design in ASDIP Wood. In the Geometry tab, you enter the geometric information, all the dimensions, story heights. In our case, the first story is 10 feet and the upper 2 stories are 9 feet. We have 3 wall segments. The first wall segment is 2.5 feet, the second is 5 feet wide, and the third one is 4 feet wide. In addition, we have openings between the wall segments. These are the dimensions of the openings. With this information, we can see graphically the shear wall. And we go to the Graph tab, then the Construction tab. This is our wall. The first step is to specify the sheathing and nailing configuration for this example. To do that, we click on the button for the database. And here in this table, we can select the configuration that we are interested in. In this case, we are selecting this wood structural panel. The thickness is 19/32 inches, 10D nails spacing at 2 inches. For this configuration, the shear strength is 2440 PLF per panel. We select this panel, and then we have these results. In this case, the shear strength is double because the sheathing occurs at both sides of the studs. If we go to the Studs tab, here we specify the dimensions. In this case, the species regions is Western species, and then we are using 2x4 studs. For other sizes, we click on this button and you are presented with the different options here. The stud spacing is 12 inches across the width of the shear wall. In the Materials tab, we specify the species, is Douglas fir in this case, grade is number 1. For other type of materials, we click on this button and we are presented with this database where we can select different options. And these are the corresponding reference design values for this material. We click on the Loads tab, and here we enter the information given in the statement of the problem. Dead load is 300 PLF, live load is 200 PLF, and then wind 1000 pounds, concentrated load at the top of the level, and then the seismic is 1200 pounds. Please note that we are entering this information for the story 1, so we just copy all the loads information to all stories with this button. In the At a Glance tab at the right, we can see a summary of the results, the geometry information, the sheathing information, shear strength value, then the calculated adjusted design values, and then the calculation of the core stresses and the bearing stresses. Here we can see immediately if there's any deficiency. For example, in this case, the maximum compressive stress ratio is 1.35. We are 35% over the maximum allowable, so it's not acceptable. We need to check this issue in further detail. To do that, we go to the next tab, the Contents tab. This is a more detailed set of calculations, grouped by topics, also by load combinations. We scroll down to the shear strength. Here we are presented with a table per story and per segment. the segment width, and then the aspect ratio. According to the aspect ratio, the program determines if the segment is valid to contribute to the shear strength of the system. For example, in this case, the segment 1 is not valid, so it doesn't contribute at all to the shear strength of the system. But the segment 2 and the segment 3 are valid, and they contribute to the shear strength at all levels. So these are the values that we are interested in. Please note that the program shows the shear strength for wind and for seismic, because these capacities will be used later in the calculations. In the next table, the program calculates the storage shear in pounds per the controlling load combination. In this case, seismic is controlling the analysis, and the table shows the result per story, calculates the storage shear, and then compares it versus the seismic story strength. The maximum utilization ratio is 0.18, which is very comfortable. That means that we can optimize this later on. In the next table, the program calculates the tension core analysis, and this is a controlling load combination for that case. Note that also the seismic is controlling here, but it's a different load combination. The table shows the analysis per story and per segment, then calculates the gravity loads, the seismic overturning moment, the gravity resisting moment, and finally the program calculates the axial tension loads in the chords. Here the maximum axial load in tension is 5,800 pounds. That occurs at the first level and the segment number 3. Then in the next table, the program calculates the compression core analysis for the controlling load combination. Note that this load combination is different than the tension core analysis shown before. The table shows the analysis per story and per segment, calculates the gravity load, then the seismic load, which is controlling, and finally the program calculates the compression axial load at the chords. Here the maximum compression axial chord load is at the story 1, segment 2, about 12,000 pounds. With this information, which is the maximum tension and the maximum compression, we are able to design the chords. To do that, the program calculates the adjustment factors for the controlling load combination, and that applies these factors to the reference design values to obtain the adjusted design values, which are these. And finally, the program calculates the core stresses in tension and compression. We can see here that the compression is failing, so we need to address this issue as well. We will go to the Detail tab. It's a more detailed set of calculations, step by step, also grouped by topic, but with references to the NDS code. Here we have the section properties of the studs, 2x4, then the reference design values from the database, then the calculation of the shear strength presented before in analytical form, the calculation of the storage shear, and here the calculation of the tension core analysis for the controlling load combination. Here the compression core analysis with the controlling load combination as well. Here is the calculation of the adjustment factors per the controlling load combination. Then we apply all these factors to the corresponding reference design values to obtain the adjusted design values per this load combination. We use these adjusted design values to perform the design. Here is the calculation of the core stresses for the story 1, segment 2, segment 3. Everything is passing for tension. Then in compression, the segment 1 is passing, but the segment 2 is not passing, and the segment 3 is not passing either. So we need to address these issues. Then the calculation of the bearing stresses is okay. We go to the Graph tab, Diagrams. The program generates interaction diagrams for the chord elements in compression and in tension. Everything is inside the usable area, so the design is acceptable. Let's go back to the Detail tab. Let's fix these two deficiencies here. The issue is in compression, so probably we need to add more members to the chords. Right now we are assigning 3 studs per chord. Let's add one more stud per chord. Now this is passing. This is not passing, but looks like very close. Go to the At a Glance tab, and the ratio is just 1%, 1.01. The shear strength ratio is 0.18, so it's very comfortable. That means that we can reduce a little bit the capacity if we want to optimize the design. Instead of this configuration, we can select a different thickness. For example, 1532. Instead of 2 inches spacing the nailing, we can specify 4 inches spacing. Let's try that selection. Then the ratio is 0.34. We can optimize the design even further if we want. We go to at a glance to see the final design. Let's say that we accept the 1% overstress. Then in the Condense tab, we have the final set of calculations in Condense format. And then in the Detail tab, the final set of calculations in Detail format. Finally, graphically, we have the final diagrams. Everything is acceptable. This is the overstress portion. It's only 1%. It's probably acceptable. Otherwise, it's very easy to fix. As you can see, it's very easy to design multi-story, multi-bay wood shear walls using ASDIP wood. We were able to design this system in just a few minutes that otherwise would take probably hours if we try to do it by hand. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.